Here we go. We have a question, most profitable path in a tree. So there's a very big description. So uh, it specifies there's an undirected tree with value 0 to n minus 1 rooted at 0. You're also given edges. There's a undirected path from A to B. At every node I, there's a gate. Also given amount array where amount denotes the price need to open the ith gate if the amount is negative, and the cash reward obtained on opening the gate opening the gate at a value at node I otherwise. So it means to open the gate, if the amount is negative we will get some value, and if the amount of I is positive, to open that gate we will get that value. The game goes on as following. Alice is positioned at 0, Bob is positioned at Bob. At every second, Alice and Bob each move to an adjacent node. Alice moves towards some leaf node while Bob moves towards node 0. For every node along with their path, Alice and Bob either spend money to open the gate or accept the reward. If the gate is already open, no price will be required. So nor will there be any cash reward. So it means we have given an amount. So whenever Alice or Bob reaches a particular node, so if suppose Alice reaches first, he will get the reward, or he will pay the amount, whatever that the case. And Bob reaches last, so Bob will do nothing. If Alice and Bob reaches simultaneously, they share the price or reward. In other words, if the price to open the gate is C, they will both pay half the price. Similarly, if the reward is C, they will each get C by 2. If Alice reaches leaf node, she will stop. If Bob reaches 0, he will stop. Note that these events are independent of each other. We need to return the maximum net amount Alice can have if she traveled from the optimal leaf node. So Alice is positioned at 0. Alice is positioned at 0 and want to reach a leaf node. And so there may be multiple leaf nodes. So we want to return the maximum path. But in this path, Bob can be there and Bob will get the amount or pay the money, whatever that the case. So Alice here and Bob here. Bob will pay this amount. Alice will pay this amount. So Alice net amount is minus 2. Then Bob reaches this. Alice also reaches this. So this node reached Alice and Bob both. So they will both get half the money. So 4 by 2 is 2. So 4 by 2 is 2. So 2 minus 2, the total cost Alice have is 0. Then Alice will move here. So minus 4, but minus 1 is already taken by Bob. So he don't have to pay anything. Then he will reach this node. So he will get this reward. So the maximum amount is 6. That's all. In this case, Alice is here, Bob is here. Alice pay this, Bob get this. Alice will move to this value. This is the leaf node. Then on this value, Bob is already taken the reward. So Alice cannot do anything. That's the maximum path that Alice can get. So this is the maximum value. And that's all. Now let's build the approach. I hope you got the question. And there's a very big description. I hope you got it. Now let's build the approach. So Alice is here on position 0 while Bob is on position 3. So we need to check on what time Bob will reach any node. So first of all, Bob wants to travel from Bob to 0. So Bob is this index. So on he will reach node 3 on time 1. Okay. Next he will try to go here. Okay, he will go here, then time 2, but on this path he cannot reach 0, so 4 will be removed. He will follow this path, so he will reach node 1 on time 2, then he will go here, so he will reach 2 on time 3, but this path also does not lead to 0, so we will just remove 2. Then he will follow this path, so he will reach 0 on time 3. Okay, we got it. That's the Bob traversal. Then what about Alice traversal? Alice wants to start from 0 to a leaf node, to any leaf node. So he will first start from this, then he will reach node 0 on time 1. So this is the node 0 is also visited by Bob, but Alice reached this first. Alice reached this node first, so he will get the reward or pay the amount, whatever that's the case. So he will pay -2. Okay, the next node he will visit is this. So next node is 1 on time 2. So one node is also visited by Bob on his path from Bob to 0. So he will reach the same node on the same time. So whatever the amount here, he will get half the amount. So 4 by 2, which is equal to 2. Okay, next he will try to go here. Okay, so he will reach node number 2 on time 3. Node 2 is not visited by Bob, so he will get the full amount. The amount is 3. So this path, if he reach this leaf node, he will get 3. This is the maximum till now. So can we follow another path? Can we visit another node? Let's check. So he will not reach 2, so just remove 2 from Alice path. So he will reach this node, so he will reach node 3 on time 3, but node 3 is already visited by Bob, and Bob visited node 3 before Alice. Alice reached on time 3, but Bob reached on time 1. So Alice don't have to do anything, so just +0. Next he will go to this, so he will reach node number 4 on time 4. So he will get full amount because this node is not visited by Bob, so he will get full amount. The total is 6. So this is the maximum amount that he can get. Now let's do the same operation on the other test case. So this is a complex test case. So first find the Bob path from Bob index to 0. So what is the Bob index? Bob index is 0. Is this Bob index is this? So he will follow this path to reach 0. So he will reach 6 on. Okay, so this is node, this is time. He will reach 6 on time 1. He will reach 2 on time 2. He will reach 1 on time 3. He will reach 0 on time 4. So this is the Bob path. What about Alice path? So Alice will start from here and want to reach a leaf node. This is a leaf node, so he can follow this path. 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 Okay, so first of all he will reach node number 0 on time 1. So now node number 0 is also visited by Bob, but Bob visit after Alice, so he will get the full amount. Next he will reach this node, so node number 1 on time 1. Node number 1 is also visited by this, but this Bob time is more, so he will get full amount. Next he will reach this value, so value 2 on time 3. Okay, its time is 2. Its time is 2. Then he will reach 2 on time 3, so 2 on time 3, but Bob is already reached this value, reached this node before Alice, so Alice will not get this value. Okay, now can we follow this path? Let's follow this path. He will reach 3 on time 4, so 3 is not visited by Alice, so he will get full amount. Next he will reach this node 7 at time 5 and he will get the value 23. Then what's the total? The total is 7. Okay, so 7 is the total amount till now, so my answer will become 7. I think 7 is the correct answer. So let me verify it. 9, so this is minus 5, then minus 11, which is minus 16, plus 23. Yes, 7 is the correct amount. Now let's follow another path. Okay, so another path, but for some values we need so 7 we have reached this node, so then we will pop out this node because we are not visiting 7 now. Next we are also not visiting 3 and we are going this way, so we will reach 6 on time 4. So 6 visited? Yes, 6 is visited by Bob and Bob will reach first. So we will get 0. 7 minus 2 plus 9 plus 9 is there, but plus 9, so this 2 we have reached 2 on time 3, but this is already visited, so we will not get any value, so 0 plus 0. Then we have reached 6. Next let's follow this path. We will reach 9 on time 5. 9 is not visited by this, 9 is not visited by this, so we will reach 9 on time 5. We will get the amount. Next we will reach 11 on time 3, so we will get the amount. So its total is 2, which is less, so we are going back. We will going back from 11, we will going back from 9, and now from 6 we are reaching this node, so we will reach node number 10 on time 5 and we will get the amount because 10 is not visited by Bob. So this is another path. The value is minus 3, which is less. Okay, so then we will going back and we will follow different neighbor, so we will reach 2. Next we are going on this path. We will reach node number 4 on time 4. 4 is not visited by Bob, we will get the amount. Then we will reach 8 on time 5. 8 is also not visited, so we will get the amount. Its summation is minus 2, which is less. So the maximum amount that Alice can have, that Alice can get, is 7. This is the maximum amount. So I hope you got it. How we gonna solve this question? We first how we gonna approach it? We first find Bob path from Bob to 0. Second thing is find every path for Alice from 0 to leaf node, and whenever we reach a leaf node, we will just gonna stop it. So let's code this. So first let's build the graph or tree, whatever that is. And it has 4 edges, but the total node is 5. So we have edges length plus 1 nodes. Now let's run a simple for loop and build empty list. Next field our graph, and let's make this global. Then we also need on what time Bob will reach any node. So this is Bob path, and let's initialize it Bob path. So let's initialize Bob path new hash map. So Bob, let's say Bob DFS, and Bob will start from Bob. He will get the amount. Amount is not required for Bob. Amount is not required. What we need? That's it, I think. From Bob to 0. Let's say void Bob DFS, and this is our node. This is our destination. If, and we also need timer. So let's say this is time. Note that this is time. So first of all, add it. So he will reach source on time this. Next he will move to neighbors. Neighbors list dot get of source. He will visit neighbors Bob DFS source and time, and he wants to reach node number 0. If source is equal to 0, just return back, and let's say we are returning back value whether this path is possible or not. So if this path is possible, so just return. If this path is not possible, we need to remove any redundant nodes from our map, and that's it. But this is a undirected list. We also need visited. So this will track what are the nodes that we have visited. So if visited dot contains source is already in our visited, so this path is not possible. And one thing I missed is we want timer plus 1, and I hope I will get the correct Bob path. That's verified, and for now let's return 0, and I hope I will get the correct Bob path. So no, map is not there. This is Bob path, not map, and yeah, not map. This is Bob path. Then this is stack over. We have a stack overflow. Bob path, we have inserted source. Then we are going to neighbor. So neighbor and timer plus 1. So then we have again stack overflow. So we have a Bob, and this is Bob. This is 3. Then 3, he will reach node source, which is 3. He will reach 3 on time 0. So I have put that. Next, I will visit to its neighbor nodes. And yes, let's dot get of source. We are visiting to its neighbor nodes. This is neighbor. Then we have timer plus 1. If that from that path we are getting correct value, so just return true. And we are not visiting, so we also need to visit source. we also need to remove source, and now it will work. Yes, now it is saying we will reach node number 3 on time 1, we will reach node number 1 on time 2, we will reach node number 0 on time 3. So this is correct. Okay, now we want the same thing for Bob. So let's first reset our visited, and this is Alice path, and it will start from 0, and we also need amount because Alice will get some amount, and it will not return anything. Alice path, this is my source, then we also require amount. So if this source node is visited by Bob, if Bob path dot contains a source, if this particular node is visited by Bob, so we need to check if Bob visited this node on the same time, or before that, or after Alice. And we also need timer for Alice, int time. If Alice time is less than Bob time, Bob path dot get of source. If I have reached this node before Alice, before Bob, if Alice reached this before Bob, so Alice will get all the amount. So Alice will get all the amount. So let's say this is my answer. So Alice will get the total amount that is there. Or if timer is same, means both reached this node on the same time, so both will split the amount of source by 2. Or my timer is more, or more means Alice reached this node after Bob is already reached this node, so Bob is already taken the amount, already taken the reward or penalty, whatever that the case, and Alice will get nothing, so Alice will add 0. So I am not adding that line. Then one more thing, if this particular node is not there on the Bob path, so Alice will get all the amount. Yes, Alice will get all the amount. Next, Alice will move to neighbor nodes. List dot get of source. He will reach to neighbor nodes. Alice path neighbor time plus 1 amount. Yes, but we also need to take care because this is a undirected, so we also need to take care about visited and unvisited. So Alice visited this source node, Alice going back from this source node, and Alice is already visited this node. Visited dot contains source. So just go back. Alice is already visited this node. Next one thing is a leaf node. So we will stop whenever we reached the leaf node. Whenever we reach the leaf node. So what is the condition for leaf node? So list dot get. So leaf node. So what is the condition for leaf node? Source node is your leaf node, and we cannot go further. List dot get of source, there's only one way, and that way is already visited. So how are we gonna represent it? List dot get of source dot size is already visited, and this is the leaf node. 1 second. So while moving I have reached this leaf node. So leaf list dot get of source, list dot get of source dot size is equal to only one. There's only one path, and that is backwards, but we are not going backwards. So how we gonna tackle it? So list and visited dot contains list dot get of source dot get of 0. Yes, I can write that. So just return from it, or return, or I think the more clear will be alias. This is alias, and this is alias minimum. This is my answer, or let's say alias value will be more useful. Alias value, and alias value whenever we reach this node. So alias value will be math dot maximum between alias value or my answer that we are getting. So we will get the maximum amount. So I think I also need this. We can say this is the path, this is the path sum. Let's say path sum and we are adding some value in our path sum. Then this is path sum, and whatever that is, we are just adding path sum. Now let's run this, and it is giving me 8. So the amount is not 8. So let's verify it. Yes, we are not we are considering. Then on any node I want path sum. I want my path sum. So on 0 I got the value -2, on 1 I got value 2, on 2 I got value 4, right? On 3 I'm getting value 2, which is correct. On 4 I am getting value 8. 8 is not the case. So till here I am getting 2. 4 by 2. Okay. On 1 the value should be yes. So this is the case. So let me correct this. So mistake, I found the mistake. The thing is source, time and path. When I do this, so it is telling me I am reaching 0 node on time 1. Okay, so let me run this and you will get it. So if I do this source path, so it says I will reach 0 node on time 0, but I'm starting Bob. So Bob will reach this node. Bob is standing on this node and he will reach this node on time 1. He will reach this node on time 2. He will reach this node on time 3. But Alice is standing at this node and he will reach this node on time 0, which is not the case. Alice is standing at this node, so he will reach this node on time 1. So the timer needs to be 1. So timer will start from 1, as Alice start from 1, Bob will also start from 1. And that's it. I got the correct answer. So let me comment out this. And yeah, let me run it. Yes, working fine. Let me submit this and I hope it will work. And yes, we have solved this question. Now let's discuss about the time and space complexity. So Bob Bob DFS, we have first we have this. So let's say it will be order of m, or it is order of n, we can say n minus 1. So this is order of n. Then we have Bob. So Bob DFS, Bob will reach uh, any node, but he will not visit a node more than once. So its time complexity is order of n. Same for Alice. First he will reach a node, then he will not reach that particular node again. So its time complexity is also order of n. And using this we have solved this question. And thank you all for watching this video.